All right, welcome back. Math 140. Lecture 9. This is week 5 already, right? We're flying. I love it. So we are doing our massive review of the first 5 chapters. So math 140, lecture number 9. Okay. It's basically assumed, if you understand everything that we've done for the first 5 chapters, then you should be able to answer everything we do here. So I actually don't mind if you look ahead, if you have the review, the workbook in front of you, it's okay because the answers are not there, but you don't have to. I'll do everything up here. So we're starting with the normal distribution. It says, so this is 1A. Oh, what's up, man? What's your name again?
Steve.
Steve. What? Okay, 1A. Draw 2 normal curves on the same axis below that have the same standard deviation but different means. Draw 2 normal curves on the axis below that have the same standard deviation but different means. How would I do it? Yes? Just sketch. Describe what you would do. Okay, first make a normal curve. Okay, there's my normal curve. Okay.
As you move it to the left or the right.
Want me to pick it up and move it to the right? Like physically?
Yeah, just draw a second one.
So draw a second one. Okay, that's it. That's it. Same standard deviation means they have the same spread. They peak at the same point, the same height. Everything's exactly identical. The only difference is where their center is located. They have different means. That's all. 1B. Draw 2 normal curves that have the same mean, but different standard deviations. Draw 2 normal curves that have the same mean, but different standard deviations. What would I do? Sarah, what's up? So, draw 2 normal curves, same mean, different standard deviations. What would I do? Yes?
You draw 2, like, well, one, the same one, like one normal one, and then for the second one, you just make the other one wider, so like in the same spot.
Okay, now question. Huh? What? No, they're normal. They gotta be normal. Can't be skewed. They gotta be normal. But you said, how should I make it different? Wider. Wider. But it's important. If it's wider, same height, higher or lower. If it's skinnier, same height, higher or lower.
It doesn't matter.
It does matter. It does matter. It will not be the same. Huh? For which one? For wider?
Wider is lower.
Wider is lower. Someone tell me why wider is lower. Yes, but I need something more mathematical. Yes? No, same mean.
You're taking away area if you're making it lower, so you have to add more on the sides.
Thank you. Thank you. That's it. That's all I want. Beautiful. The area under the curve must be 1. One of the 2 conditions for a density curve is that the area under the curve has to be numerically equal to 1. If you make it lower and you are taking away some area, you got to make it wider to compensate, then vice versa. To make it wider, so you're adding area on the sides, you have to lower it to take away area in the center. That's exactly it. The area has to be 1. That's all you need to say. Yes?
The wider one, right?
What about the wider one?
No, like which one has to be closer to what? Can you say right now?
No.
So what are we saying right?
What I said was the area under both curves has to be equal to 1. So if you make this one wider, adding area on the wings, you have to make it lower to remove area in the center.
Yeah.
because the area must be equal to 1. Question 2. A famous test of human intelligence is the Wechsler IQ test. The IQ scores follow a normal curve with mean 100 and SD 15. What does SD stand for? Standard deviation. Your eyesight is probably got seats up front if you like. This is like the nicest 15 I've ever drawn in my entire life.
No,
Huh?
I didn't know if there was like a thought, you know.
Right. So, carefully draw this normal curve below. So if I ask you to draw this normal curve, I'm not just asking for the curve itself, but what else do I want if I ask you to draw this curve? I'm sorry? Well, there has to be enough information included with the curve that all this data that I gave you is correct. So if I draw a generic normal curve, and I have no scale yet, so any normal curve works, what would I label? Mean. What's the mean and where's the mean? 100 and right in the center. Now I don't put it up here. This is my axis. So the numbers are on this axis here. So there's 100 in the center. And how would I incorporate sigma being 15? Yeah, but 15 this way. I mean, where's
Halfway down the curve when it's done.
so halfway here? What makes this coin special?
Where it flips.
What's it, huh? Point of inflection for those of you who had calculus. Otherwise, just where it kind of flips from being kind of like a hill to being more like a bowl. So about there. So this is 115, and the corresponding point on the other side would be 85, something like that. Would then incorporate all of this information. Previously, I drew these two arrows here, labeling this 15 and this 15. That works too. But I think the 85 and the 115 is a little better because you're putting your numbers on the axis and you're not cluttering up the curve itself. So draw this curve below, label the axis with the numerical values of the means, and point 1, 2, and 3 standard deviations above and below the mean. The mean's 100. We have points 1 above and below the mean. If I wanted points 2 deviations above and below the mean, where would I go to on this axis to the right?
130.
To 130. And where would I go to the left? To 70. And my curves, not necessarily the greatest. And in fact, if I was actually doing this on a test myself, I'd probably go back and redraw my curve to be a little more accurate. Just the tails really. And just have it kind of last a little bit longer, something like that. It's just a sketch. It doesn't got to be perfect, but something like that. Does that make sense?
Yes.
Question 3. And if there's no questions, I keep going. If you have a question, shout it out. Nobody will make fun of you. We will not judge you. I mean, I might a little bit, but nobody else will. 3. The histogram below. Uh-oh. Well, okay, I'll do my best. I can't even lift that because people are watching. So you have a histogram. We can't even do this one. I'm sorry, I can't draw this histogram. Skip this question, but I would recommend that later you look at question number 3 on page 29, if possible. Just to make sure that you know how to do it. So we're going to skip question 3 just because I can't.
29.
Page 29, question 3 in the workbook. Question 4. Suppose the scores on an achievement test follow an approximately normal distribution. We have our scores, I'll label it with S. A normal distribution with mean 500. With mean 500. Minimum 350. And maximum 650. That's a question mark. Which of the following could be the standard deviation? $10? $50? $100? $150. Justify your answer. A sketch may help. It says, maybe it will, maybe it will not. I'll see if I can do this right now. Okay, I have my answer.
That was the computer.
Oh, woo, yeah,
It's me.
yeah, go ahead. What?
I'm saying, can we count like this? The free deviation will be from each below and down of the mean will be like 6 deviation included with all. We just
Start again in English this time. Go ahead.
so if we do like from 500 to 650, it will be 3 deviations.
Roughly, because we know that 99.7% of all the
Yeah.
data points fall within 3 deviations, correct? So if we go all the way to the end, it would be roughly 3 deviations. Agreed? And what if we go down to 350? How many deviations is that?
It's also free.
Roughly 3, which will put the standard deviation at about how much? At about 50. That was it. That was the entire logic right there.
Professor,
Yeah,
so you could just do, so 500 minus the minimum, 350, which would be 150, then divide by 3.
or 650 minus 500, which is max to that, divided by 3.
Does that work every time?
Approximately so. Approximately, because remember, for a normal distribution, 99.7% of your data is going to be within 3 deviations, right? Which means if I go all the way to 650, which is 150, and I get all of my data, it's going to be a little bit more than 3 deviations, which means a little bit more than 50. But if these are my 4 options, then certainly 50 is the correct one. Yes,
Could you walk through how you did it with your method
that was my method.
one more time?
Oh, well, the distance from 500 to the minimum or to the maximum is 150. So to go from the peak to either edge is 150, correct?
Yes.
But I know that to get to the peak, to the max or to the min, will roughly be 3 deviations. So 150 is about 3 deviations. So 50 is about 1 deviation. That's it. Does that make sense? Right? Okay. Question 5. Oh, and by the way, also, yes? Again, from 500, which is the mean, to the max or to the min is 150.
Yeah.
That's undisputable, correct? They gave us that information here.
Yeah.
But I also know that 3 deviations from the mean is just about all of my data. Yeah, mean, 3 deviations left to right is 99.7% of my data. It's almost everything. Which means 150 is approximately 3 deviations. which makes one deviation 50. Yes,
Then, like, if you were to start it out, you could be like the mean minus the mid over.
approximately. Approximately. Question 5. It says students' GPAs at a certain university are approximately normal. So G for GPA is approximately normal. With a mean of 2.5, mean, not min, mean of 2.5, and a standard deviation of 0.5 grade points. A. About what percentage of students have a GPA between 2 and 3? About what percentage of students have a GPA between 2 and 3? Got it.
67.
Yeah, how do you get that? Closer to 68, but anyways, go ahead.
It will be one deviation rule.
Yeah, so the mean is 2.5. And one deviation left is to 2, and one deviation up is to 3. And we know that there's approximately 68% for a normal distribution, one deviation left and one deviation right of the mean. Now, if I went to my calculator and I plugged in lower 2, upper 3, mean 2.5, standard deviation 0.5, won't be exactly 68%. This is only an approximation, but it should be fairly close. What does it give? You're nodding your head. I thought you had it.
I was gonna do it.
How much?
0.682689.
0.682 something. So approximately 68%. About what percentage of students are between 1.5 and 3.5? What percent between 1.5 and 3.5? Well, let's figure out how many deviations left and how many deviations right. 2 deviations left, 2 deviations right. That number we have again. No, 99.7 is 3 deviations. 2 deviations is 95%. So it's approximately 95%. Again, your calculator won't give you exactly 95%, but it'll certainly be approximately 95%. What percent of students have a GPA below 2? What percent are straight up below 2? Got it.
2.35.
How much?
2.35.
No,
16.
16%. Everyone take a minute. Don't need a calculator. In fact, you don't even need anything that's not already on the board. Should be enough here to understand why 16% are below 2.
Oh yeah, it's 50.85 now.
3235.
Yeah. We know that there's 68% here in the center, which leaves how much not in the center? 32%, half of which is on this side, and the half that we want on this side. So how much is below 2? 16%, approximately. A GPA of 3.5 or higher is required to make the dean's list. What proportion of students qualify for the dean's list?
You said 3.16.
Sorry?
You said 3.2?
3.5. What percent qualify for the dean's list? 2.5%. Again, right here. 95% is from 1.5 to 3.5 symmetrically, leaving how much outside of this 95%? 5%, half of which is on this side, those are the ones who fail out, and then half of it's on this side, those are the ones who make the dean's list, 2.5%. No calculator required, as long as you know the 68, 95, 99.7 rule. Let's keep going. We're having too much fun otherwise, right?
Oh wait, Professor, can you say please if this is above like 3.5, if 3.5 is 3 deviations?
3.5 is 2 deviations.
Okay, yeah. Oh, sorry.
0.5, 3.5 is 2 deviations up.
Oh yeah, gotcha.
Okay, next, let's keep going. Additional practice, it says, which means it's essentially feels, the workbook feels that it has covered everything you know for this chapter, in theory at least. And now we're throwing in some additional practice. The distribution of adult human height, the distribution of adult human heights. Okay, is approximately normal for both males and females. The summary statistics below are for American adults ages 20 through 29. Using these values, carefully sketch the female and male height distributions on the same axis. So what we have here are females and males. And their mean for females is 64.1. And the mean for males is 69.3. And the SD for females is 2.75. And the SD for males is 2.92. So the question said, sketch both distributions. We were told they're both normal. These are both normal. So it says sketch them on the same axes. So what would I do? No, I'm standardizing. I'm not sketching them on the same axes. I guess you could standardize them. I take that back. You could standardize them. No, don't standardize them. Because if you standardize them, they'll both have a mean of 0. And therefore the means will overlap, but we do not want that. We certainly want to see the difference in their characteristics. So how would I answer this question? Okay, make a number line.
50 to 80.
Okay, 50.
The box plot?
No. They want the sketches of the normal curves. Okay, 50 to 90, let's say.
And then plug in the mean, we can start with the female, plug in the mean, which would be 64.1.
Therefore,
Got it on the number line.
okay, so about here, 64.1.
And then from there, you can start getting the 70 degrees to the left and right.
What's the standard deviation to the left or to the right?
66.85 to the right. 1 to the right.
Okay, what do I do with that information?
We're going to put down the numbers. So you can make the-
Okay, so 2.75 to the right is about here and about there, give or take. Okay, now what? Okay.
The needle move? Oh, so then now we can just know.
Huh?
Now we can just-
Oh, no, this is just females, one at a time. Let's do females. So now that I have this, all I need. How do I sketch my graph?
You just, you have the peak at the 64.1. And then as it goes out, the point of inflection on each side of the deviation mark. And then you can draw like that.
Okay, something like that. That's the females. How do I draw the one for the males? 69.3, which is about there. A little bit flatter because it's a little bit wider. So it's a little bit flatter and it's a little bit wider. So something maybe like that. Again, it's just a sketch. Okay, but the idea is have the means in the right place, have the male mean slightly lower than the female mean, and have the male graph slightly wider in terms of how it's spread out than the female graph. The rest of it's just a sketch. It's not going to be perfect. Yes.
If this were to come out on the test, would we have to label all the numbers or just?
No, in fact, in hindsight, I never would have gone 50 to 90. I would have had this whole thing 50 to 60 or 70 maybe, and have them spread out. But
Wait, so the group that has the larger mean and standard deviation?
not mean the larger standard deviation needs it more spread out. If it's more spread out, it has to be flatter. Just sketch them. Yeah, just sketch them. You're given this, sketch the
Are
curves.
we ever gonna have to do like sketch it out? and,
No,
like,
I will not ask you to do that. It's in here, but I will not ask you to do that. No.
Oh, and then I asked a question. Are we with like on the final? They're gonna give us like a Z like score like
Maybe,
the chart.
maybe. You have a calculator, what do you need it for? Calculators do everything. Z table is completely unnecessary if you have a calculator for it. Now, if your calculator breaks, or you don't have batteries, or you forget it at home, you certainly might want to know how to use the Z table, just in case. Yes.
Where's the, you put a link to rent a calculator somewhere?
To what, to what?
Didn't you put a link somewhere to rent a calculator in the library or something?
Oh, I don't think I put a link, but
It was in syllabus something. about-
somewhere in the syllabus might be in there. Okay, next question. Next question. Let's skip that. Okay, so I'm skipping question 2 and the additional practice only because it's completely redundant with what else we've already done today. No additional information here. So now we're moving on to page 32. Still in chapter 3, working with normal distributions. Question number 1. Your Z-score is -1.8. In words, what does that mean? And I don't want you to just say, oh, in words, your Z-score is -1.8. That's not what I mean. Yes.
Is it on a standardized curve where the mean is 0? Maybe 1 point is 1 standard deviation away.
You started great, but you didn't finish great. Yes.
The formula, like data minus mean?
No. In words, yes.
Whatever normal curve you're looking at, it's 1.8.
It's, what is it? Said it. I don't know what the word it means.
Your data point.
Okay. No, not your mean. Not your mean. No, certainly not. This is why it's important. The word is the worst word in math. Because wait, one second. We use the word it as a catchphrase for something, but the precision that we need, it's horrible. So your data point was correct. The mean is not correct.
What would the mean be though? 1 or 0?
I don't know what the mean is. I have no idea what the mean is. Oh, you mean with the Z-score for the mean? Oh, 0, of course.
0.
Yeah, but so finish what you're saying.
The data point that you're looking at is 1.8 standard deviations to the left of whatever normal curve you're looking at.
You're not so good until the end, the ending.
The most important normal distribution of all.
Oh, you're just reading stuff. No. You're just reading something. No. Shut up. No. You were doing great till the end. The last thing you said was a mistake. Everything until then was perfect.
1.8 deviation to the left of the mean.
Of the mean. Your data point is 1.8 standard deviations to the left of the mean in whatever curve you're looking, in whatever normal distribution you're looking at. Not left of the normal curve. That doesn't make any sense. The whole thing's a normal curve. Right? It's 1.8 inch. I just said it. The data points, your data points, the data point under consideration is 1.8 standard deviations less than or to the left of the mean. That's exactly what a Z-score is. It tells you how many standard deviations away from the mean you are. In this case, 1.8 to the left. 2, the weights of adult male rhesus monkeys are approximately normal with a mean of 15 pounds and a standard deviation of 3 pounds. What is the probability? What is the likelihood? What's the chance that a randomly selected monkey weighs less than 15 pounds? 50%. Too late. You're way too slow. 50%. Normal, we know the peak's at 15. So half of my data in the world is going to be less, 50%. B, a little more challenging now. What proportion of monkeys weigh less than 13 pounds. What percent of monkeys? Yes,
25%.
20. Where do you get that from?
I remember doing like workout things, and it's 2/3 of the standard deviation.
Wow, good for you. Because I didn't remember that. So that's nice.
Professor, Professor,
What?
Professor, I have a question. How we count it without this score? I mean, how will we count it in the calculator? Not with this score.
Don't use these scores.
Oh.
Don't use these scores. Put in this information in your calculator. You don't need Z-scores for this. If you want to use these scores, what's the Z-score for 13?
It will be negative 0.666.
Okay, so then you go to your calculator again, or you go to a table, and you look up the likelihood, the percentage of data points that are less than negative 0.66666. What do you get? What does the calculator give us? 25.25%. But this is the beautiful thing. He remembered a problem and it stuck in his memory. So he was able to use that to solve another problem.
How did he do it?
Yeah, I was gonna say.
He said he remembered that if you go 2/3 of a deviation below the mean, it's 25 cents past that. I didn't remember that. I've been teaching stuff for years. I didn't remember it. I didn't try to. I can do my calculator in 10 seconds, so I didn't bother.
How did you do the calculator?
Negative infinity to 13, 15 mean, 3 sigma, calculate 25%. Or 25.25%. Lowers negative infinity. Less than 13, all the way to negative infinity. Yes.
Sometimes when we put on negative 9999, it says that there's a mistake.
No, if you do minus 9999, it's a mistake. If you do negative 9999, it's not a mistake. Your calculator differentiates between a minus sign and a negative sign. Okay, 5 minus 3 is a minus sign. Negative 3 is a negative sign. You do the wrong one, it'll say error. So look at your calculator. There's different buttons for the negative and for the minus.
Oh, that's what it's happening to me. That's what-
Yeah, it's a not a minus, it's a negative. And mathematically, they're different too. A minus sign is what we call a binary operation. Guys, a minus sign acts on 2 numbers. You can't just say, hey, what's minus 7? Doesn't make any sense. I can say what's negative 7, that's perfectly fine. You can't say what's minus 7. Negative 7 is the additive inverse of 7. It's what you add to 7 to get 0. Very different things. Of course, even I will at times use the wrong one. If I say plus or minus 6, I really mean positive or negative 6. Well, we say plus or minus, it's natural, right? Sometimes we use letters for numbers. Anyone here guilty of using a letter for a number? You probably did today. Using a letter when you should use a number instead. Like 0 and 0. Like what height would you take to get here? The 405? Right? It's the 405. Nobody does that. Is that me? But I'm like weird. Okay. What proportion of monkeys weigh more than 20 pounds? 25%. I said it like 19 times. 25%. 25.25%.
Wait, more than what, 20?
Huh?
Way more than 20 pounds?
Now I want more than 20 pounds.
13 pounds, right?
The 13-pound one, the answer was 25.25%. Now I want more than 20 pounds. 4.78%. Again, the number doesn't matter as long as you know how to do it, that matters. Sky, I can't hear.
Negative infinity to 13 would give you
25.25%. Yeah.
Can you say what you get? 4.8%?
4.77%.
Okay.
What are the weights of the lightest 10% of monkeys? What are the weights of the lightest 10% of monkeys?
Right now, the calculation or no?
Huh? I just want the answer.
I mean,
What do you mean?
like what you're doing on the calculator,
Well, I mean,
just to like make it, I don't know.
you tell me what we're doing. I'm not doing it. You tell me how to answer this question. How do I answer? No, you tell me. If I say, what are the weights of the lightest 10% of monkeys? How would I go take my calculator and get the answer?
But I think he's talking about the last, like the last.
No, this one, the last one's all the same. He's asking for all of them. Okay, I'm not gonna write down what I'm doing because I already made a detailed thing when I actually taught the class a couple weeks ago, and I put down on the board, put this button, then this button, then this button. But now, as we're reviewing, I'm more than happy to walk through it. So someone answer, how do I calculate the lowest 10%? Yes. Scott, I cannot hear.
You want me to give you actual calculator presses?
Just tell me what your strategy is using your calculator.
You use inverse norm,
Inverse norm,
0.10.
0.10,
And I enter in the mean and standard deviation.
beautiful.
Yeah.
What was the answer? No one said the answer. What's the answer? 11.15, 11.16, something like that. Anything less than 11.16 pound would be the lowest 10%.
Okay, so that's part of the lowest 10%.
I don't think you'd be at a disadvantage. I can't promise that I know how to do everything on that. So you're on your own to figure out the commands. Yes. I cannot hear. It's not fair to someone asking a question. Yes? That's your answer. Well, the lowest 10% will be all the monkeys that weight and below. That marks off the lowest 10%. This is for everyone. We'll all get different answers. Everyone find your percentile. Find your percentile. Even though technically the data for that is 20 to 29-year-olds, some of you might be lower or over. Let's assume that this holds for all of us. Everyone find your personal percentile.
What's the variable?
Height.
Height.
It's the same data that we used in the example. Height. Find your percentile. And then look around the room and ask yourself, who do you think here would be the highest percentile? I didn't say that. Yeah.
How do you do if the range is 20 to 20, the minimum is 20, the max is 29, and you're like 18?
Height?
Finding the percentile of your age.
Height.
Oh, I'm sorry.
It's okay. Everyone find your own percentile.
Like
You
out of the
said
male one?
workbook, so are you mean like the physical book or?
Well, I
what
mean,
is the workbook that you're referencing?
under files.
Under file?
It's an online workbook, huh? Find your percentile. You got yours? I cannot hear. Yes, you do. You're kidding, right? No, you're not. Yes, you have to be able to convert your feet to inches. Now, once you convert your feet to inches, how do you find your percentile? Yes? What?
Normal CDF.
Normal CDF,
The negative infinity.
negative infinity,
My.
your height,
The mean of male and the standard deviation,
beautiful. So what do you get for yours?
80%.
You're in the 80th percent. How tall are you?
6'5".
You're not 6'5".
I got 59%.
59%?
Yeah, close enough.
Okay, 59%. Anyone got higher than 59%? 59%. 59 percentile, huh?
89.
How much?
89.
You're not in the 89. How tall are you? How tall are you?
6'1".
I'm in at 82%.
Okay, maybe you are.
Yeah. 6'1".
So 6'1" would be 61 inches, would be 60,
Wait,
73.
73, yeah.
73 would be about, okay, I'd see that. Okay, 89 percentile. Huh? No, that's about right. Yes. Okay. I'm with you. I'm with you, yes.
For the percentile,
I cannot hear.
for the percentile, like let's do.
Hold on, guys. You're doing math, I love that. I really do. But if someone's asking a question I can't hear, I do not love that. So let's use our whisper voices if we're going to communicate, not our low murmur voices, which build to a crescendo or a crescendo. I'm not actually sure how to pronounce it, but our whisper voices. Yes.
Let's just say like any random percentile.
Hold on. Seriously, I just asked and you're still doing it. Whisper, don't murmur. It's loud. Yes?
For any random percentile, like 60%, would that mean that you're the upper 60% or the lower 60%?
Well, that means you are above 60% of the data.
Okay.
So you are in the upper half if you're at the 60th percentile.
Okay.
You're in the 89th percentile. I'm envious, I am. Anyone higher than 89th percentile? Philip, what do you get? Guys, seriously? Huh? 9.4? So the 95th percent. How tall are you? 6'2". 6'2". It's a good height. Not that tall. Okay. Huh? I'm like 5'8" and a little bit. I'm in the 32nd percentile. It's bad. Okay. Now, if we went by weight, I'd be like in the 99th percentile. So I'm good at something. That's all I can say. Okay, next question. Find your percentile if you were the opposite gender. Find your percentile if you were the opposite gender. Find your percentile if you were the opposite gender. I'm not going to ask anyone what their percentile is now, but find your percentile if you were the opposite gender. And then answer the following question. What percent of the opposite gender are taller than you? What percent of the opposite, seriously, guys, really? What percent of the opposite gender are taller than you? So you should be able to calculate your percentile using the information of the opposite gender. And then how would I answer the question from that? Suppose you got, yes, you want to volunteer?
Yes,
Okay, what do you get?
I got 12.9.
For your percentile?
Well, no, for my percentile, I got 87%.
Okay, so you'd be at the 87 point whatever percentile of the opposite gender. And as a result, how did you calculate what percent are taller than, what percent you're taller than?
I did 1 minus 0.87.
1 minus that will give you the right answer. Very good. Yes.
So if you're the 90th percentile of the opposite gender, and you want to find out how much are taller than you,
That will be the other 10%.
1 minus.
1 minus whatever you got. Okay. Yes.
So we always do that, the 1 minus whatever.
Well, the percentile is automatically what's beneath you.
Okay.
If you're interested in what's above you, it's 1 minus that.
Okay, so we always do that when we try to find a percentile. Or
No, again, you have to read the question. I can't say always. Every question is different. The percentile is what's to the left. If you want what's to the right, you do 1 minus that. But I'm not giving you a blanket always do something statement. All right. So that's it for chapter 3 on normal stuff. Questions? What do you have to know in this chapter? Percentiles, Z-scores,
CDF and norm.
normal CDF and inverse norm.
Z-score.
We said that. Mean, deviation, what these things mean. It's not actually a lot of information. If you actually collate it down to what you have to know for chapter 3, it's like 5 things. It's not a lot of information. Yes,
In your opinion,
the answer is no.
oh, for everything we've learned so far, how much harder does it get?
Can't answer a question like that.
Why?
Difficulty of material depends upon your knowledge of the material. If you know it, it's easy. If you don't know it, it's hard. I can't answer a question like that. I have no objective basis. To me, it's all easy, right? So I can't answer a question like that. Yes.
Usually, how much does the class go down in percent
Now that you can answer.
when?
That you can answer. Well, so you have a couple things. Are we taking into account people who stop showing up and stop taking tests?
No.
So just the ones who continually work through the whole course. The scores tend to go down.
How much, like 15-20%?
I don't have it off the top of my head. 17.2%. No, I just made it up. I don't know. Yes,
So people from their past classes would say it's gonna get harder.
I can't answer that. All I can say is scores tend to go down as the semester progresses. And you know why scores tend to go down?
They give up.
Well, there is that, but Z-scores, for example, the normal stuff, we'll be using the entire semester. So if you don't have it down now, when all I'm asking is Z-scores, how are you going to do later when you have to apply them in the context of a different problem? You don't know the basics, you can't apply it to the harder stuff. So what happens is you have a somewhat shaky foundation, and then you learn more material. So you're building a house above a weak base. What's going to happen? You'll never be secure. Know this stuff well, and the rest of it becomes easy. Don't know this stuff well, and it will all be hard. Yes. No, I want to go on because they're all the same. There's anything else is redundant at this point. It's all on video. You can watch it later. They're all the same. Okay. And in the interest of time, I want to go on. So, I'll do scatter plot and correlation next time. So let's go back to the previous chapter, chapter 2, and let's answer some of those questions. Okay. So some of them have, visual displays here that will just take too long to go over, but I can try to ask questions that are based upon them. If I give you a dot plot, or a histogram, how can you roughly estimate where the mean is located? Yes. The middle is not correct. You're assuming it's symmetric. Maybe it's skewed. Yes.
Your highest point.
Definitely not the highest point. That's the mode. The mode is the highest point, but not necessarily the mean. Yes.
Median?
Mean and median are two different things. Yes.
It's gonna be skewed to wherever there's outliers.
Yes, but again, not answering my question. I want to know there's the mean, or there, or there. How can I get a rough estimate for where the mean is located? Yes. That's it. If you build the histogram, if you construct it out of wood or steel or something solid, and then you try to balance it on your finger, wherever it balances, that's the mean. The mean is the balance point. What's the median? What do you mean by the middle? The center? So what is the median? No, that's the mean. That's a mathematical way of getting the mean. Again, I'm looking for a graphical way. The graphical way was the balance point. If I want the exact value of the mean, sure, add them all together, divide by how many you have, 100%. How do I find the median?
Like the data point exactly in the middle or 50th percentile.
So be a little more, I'm not saying you're wrong, but just be a little more specific in how to find it.
Like if you were to go, if you had a data set and you were to go halfway up, it's like going by each data point, it would be the one exactly in the middle. So 50th percentile.
Okay, So are you not differentiating between having an odd number and having an even number, or does it matter? Or do you want to be a little more specific in your answer?
If it's even, then you want to go halfway in between the one that's like closest to the middle on the left and the closest to the middle on the right.
And do what with those two numbers?
Add them up and divide them by 2.
Okay, and what if it's odd?
Just pick the one in the middle.
Okay. To find the median, you put the data points in order from lowest to highest. If there's an odd number, the median is the one in the middle. So if I have 99 data points, which of those data points, when listed from lowest to highest, is the median? No, not 51, not 49. 50th. Again, the number of data points, you add 1 and then divide by 2. 99 plus 1 over 2 is how much? 50. The data point is a 50th. 49. 49 makes 98. So what's the one after the first 49? The 50th, the one in the middle. The n plus 1 over 2 approach always gives the median when it's odd or even. Because if I have 100 data points, an even number, how do I find the median? Well, take your data points, 100, add 1, divide that by 2. What do I have now? 50.5. What does that mean? 50.5, halfway between the 50 and 51st data points. So the n plus 1 over 2 approach always works for even or odd. So if I give you a certain number of data points and I say, which one's the median? Easiest way of getting the answer. For a symmetric distribution, where are the mean and median located? Same place, more specific. The highest point, I know what you're trying to say. That's the same thing as saying the highest point. But I didn't say it was symmetric like this. Maybe it's symmetric like that.
But we're not doing that in this course.
Why not? I can make any, if my data looks like this, it's not normal, but the mean in right here in the center is still symmetric. Yeah, well, I might not do any math with this, but I can still do a graphical question with this. Right? So to say the mean of the highest point would not be correct. Even if it's normal. The mean and median, you say, oh, the highest point. Well, not technically. Technically, it's there. It's at the x value that corresponds to the highest point. But it's not technically the highest point. That's just the value of the function or the count. The mean and median are at the center of the distribution if it's symmetric. What if it's skewed to the right? What if the distribution is skewed to the right? No. No. Wow. Crazy. How do you figure that one out? So if it's skewed to the right, if we have a tail on the right side. So this point here, if I had to give that guy a name, what would it be called? It's not the median. It's certainly not the mean. This is the mode. The mode is the one that occurs the most often. The one that occurs the most often is going to be the peak. Are there modes here?
Yes.
Where are they? There's 2 of them. The mode, don't even think about it that way. Don't think about it that way. The mode is where the peak is. Skewed right, skewed left, symmetric, it's all the same. The mode is where the peak is. It's the highest point, or the point that corresponds to the peak. Now, when it's skewed to the right, where are the mean and median located? Are they also at the peak?
No.
Is one on the left, one on the right?
They're both.
They're both on the right. Do they get pulled to the right the same amount?
No.
Which one gets pulled more? The mean gets pulled more. Yeah, okay, 50-50. Give it a shot. I don't blame you. The mean gets pulled to the right more. Why does the mean get pulled to the right more? I'm looking for a very specific answer here.
Less resistant.
It's less resistance. The mean is a non-resistant measure of center, mightily affected by high values. The median, on the other hand, is a resistant measure. Might not be perfectly resistant, it still moves a little bit, usually just not that much. Yes.
Because of the outliers, right?
Well, they don't necessarily outliers, they may be outliers. They're possibly outliers, but certainly because of the high values, whether they are outliers or not. If it's a left skew distribution, what would change? Yes, the mean we pulled further to the left than the median, and the mode would still be in the center. Now, I just want to throw in something here. It is possible to devise histograms where this is not true, but you're not going to have it in this class. So in this class, you might see questions like, what is usually the case? Or where is the mean usually? Or the mode or the median usually? It's because there are ways of constructing data where some of these rules don't get satisfied. Yes?
One behind that potential.
Yeah, this is bimodal. Right, the most number of modes you can have is 2, by the way. We don't talk about trimodal graphs. It's either no mode, 1 mode, or 2 modes. I don't make the rules, I just break them. All right. Stem plots. There's a stem plot here with lots and lots and lots of numbers that I do not want to copy over, so I'll just ask conceptually, how do you make a stem plot?
Depending on the center one.
Okay,
So if they're ones, you're gonna put 0 on the left side, and then you put the thing of the number, and you go and put it 10, you put the 1 on the left, and then each point at a point to the right that you encounter.
question, if you were trying to teach someone for the first time, do you feel that explanation will be enough to explain it?
I'll probably draw it.
Probably draw it, yeah, me too. You're right, 100%. A picture says 1,000 words, so I will not draw that stem plot because there's too many data points there. But a stem plot might look something like this. Someone tell me, first, how many data points do we have in the stem plot that I just created? There's 14 data points here. What is the highest data point? No. If you make a guess that you think is right, not a guess, but if you really have you really believe you understand something, and I say it's wrong, don't immediately throw it out and just say something that's nonsense, that you know is nonsense. Try to understand why your answer is not correct. The guess was 61. I said no. Why is it not 61? Yes.
By highest data point, do you mean the mode or like the?
No, the biggest number. Yes.
Would it be between 8 and 48?
No. Yes,
Would it be between?
because it's this one. Huh?
Would it be between 19 and 20?
No. Yes?
Well, I was gonna say, because then 61 is gonna be an outlier.
No. Maybe it is, maybe it's not. Yes?
Is it a complete data set? Like,
Yes.
is it more massive?
No, this is it.
You say it's approximate?
No, these are the exact data points.
Is it the number that has the most data points?
No, it's one there at the end. I don't see 61 there. I mean, it might be 61, but what are some other possibilities that it could be? Could be 610, it could be 6.1. It's certainly this data point, but I don't know what my stem and my leads correspond to, because I didn't give you that information. If my stems are in the units place, and that these are the tenths place, then this is 0.2, 0.2, 0.3, 0.4, 0.8, all the way to 6.1. If those are the tens and these are the ones, that's 61. See what I'm saying?
So whole number is always on the left.
No. The last digits of whatever number you are displaying, only the last digit goes here. All digits prior go here. But I didn't tell you whether these are 61 or 6.1. I didn't give you that information. So this, whatever number this is certainly the highest data point. But it's not necessarily 61. This is what I said. If you make a guess, because I know how stem plots work, that's 61. No, it's not. Don't just jump and say, okay, let me just come up with something else. Try to understand where is the nuance that I'm focusing on that says it's not 61. Make sense? Yes? Okay, yes.
Do you plan on asking something like this?
Why not?
Huh?
Why not?
Okay.
Fair game, yes.
Is there a possibility that that could be 6.01?
No.
No.
No, you won't have a gap in between. Unless every one of those numbers had a 0 in the 10th in the 10th spots, then maybe, but
Would that only work if you,
I've never seen that happen.
would that only work if you doubled it, so you had 2 sixes? Yeah,
If I what?
6.01.
6.01, you mean?
Yeah.
Yeah, but if I had 6.01, then I'd have to have something like this as my last one. Because only the last digit goes on the right, all previous digits go on the left. So if I had 6.01 and 5.9 whatever, and 5.8 whatever, and 5.7 whatever, I can do it that way. But the key to remember is 2 things. The last digit goes here, so that each one of these numbers is 1 data point. And that you need to know from the context where the decimal place is located. Okay, that was the key that I was trying to point out there. So when you get a question, read the question carefully. If we're talking about, for example, population in America, and these are all different states or cities, and you have this, then what does the 6.1 mean? Does that mean there's a city that has 61 people in it? Probably not, huh? Well, I don't think any city has I don't think any city in the, maybe Mexico City. Anyone know how many people are in Mexico City? That's a lot of people there. It's like 100 million people in Mexico City or something like that, some crazy number. But in general, if I had to take a guess, I would say that's 6.1 million. Right? So again, you have to know for the context what you're for. Yes? Doesn't say what?
Like if it is 6.1, it does say 6.1.
Well, I mean, if I wanted to, I guess I could make those 6.1. I guess I could do those if I wanted to. I don't see why not. I've never seen it done, but maybe for clarity you could, but you don't have to is the point. All right. While we're here for this made up data set, let's assume, by the way, it is 61 and so on. So this is my own construction here. Most likely in the history of time, and all the millions and millions of statistics classes that have been taught in the last however many hundreds of years, this might be the very first time this particular stem plot has ever been used. So we should all feel very special right now. What is the what's the IQR? And again, we're going to assume this is 61, just for the sake of this example. We will assume the context was given and it is 61. Yes.
2 and 61.
So the IQR is 2 and 61.
Between 2 and 61.
The IQR is a number, right? The IQR is a number.
Is it Q3 minus Q1?
It is Q3 minus Q1. So if you're going to find the IQR, you better first find Q3 and Q1. And if you're gonna find Q3 and Q1, you better first find what? The median. So you can't just jump and say, here's the answer. There's some work that has to be done. So let's go ahead and find the median.
So the interquartile range is the area between Q3 and Q1, right?
It's the what?
The area between.
No area. Not the area. What is the IQR? You get Q3 and no, I don't care, but I'm saying in general, what's the IQR? Q3 minus Q1, a number minus a number, no context of area. It is whatever the Q3 is minus whatever Q1 is. So first Q2. No. This is 61 there at the end. So what is the Q2? 22 and a half. So Q2 is 22.5. Anyone not get that or not sure how to get that? Speak up now. Q2 equals 22.5. Who said me? A brave soul, sing me. How do you find Q2 in general? For the median, how do you find that? If I give you, don't look down. If I give you data and I say, find the median, what's the first thing you should do?
I would add everything up.
No, that's the mean. How do you find the median?
Sorry, individual points.
No, well, kind of. Huh? Add plus 1 to what? Add plus 1 to what? The number of data points. How many data points are here? 14. Add 1 to that. Divide that by 2. 7.5. Does that mean the median is 7.5? I didn't write 7.5. What does that mean if I say it's 7.5? It's where the median is located.
It's IQR 2.5.
I haven't gotten that far yet. I don't know. I literally haven't looked further than this. So the Q2, when we say it's 7.5, what does that mean at 7.5? Huh?
Between 7.
Between?
7 and the 7 and the 8 numbers. Not the number, the data point.
Data points. Halfway between the 7th and 8th data points. 1, 2, 3, 4, 5, 6, 7. The 7th data point is what? 19. The 8th data point is what? 26. What is halfway between 19 and 26? 22.5. Add them up and divide by 2. That's how you find Q2. Yes.
Would it be okay if I just plug it into list 1 and then did 1 bar step?
Yeah, your calculator can do everything for you. Yeah.
You're still at plus 1 divided by.
Sure. So now the median was right here in between 19 and 26. How do I find Q1? Without the calculator. I know the calculator can do it, but how do I find Q1 without the calculator? Yes?
No, I have a question.
Yes.
So, actually, would you use the same formula for finding the median?
Yes.
as-
Yes. Yes.
You find the value that's in between the first 7 points.
Okay. Well, be more specific.
The first 7 points, you find what's in between, so you're looking for the fourth point.
Okay. So the median is here. You look at all the data points less than the median. How many data points are there less than the median? 7. 7, right there. 7 data points. And you do exactly the same thing. 7 plus 1 over 2 is 4. The 4th data point. Fourth data point is 4. Now, how do I find Q3? Yes.
2 questions. 1, will there ever be a situation where we're not allowed to use a calculator to find all this?
Not in this class.
Or in the final now?
Not in this class.
And for Q1 PT, isn't Q1 just the 25th percentile? Q did the 75th percentile?
Sure.
Okay.
Yes.
Do the same thing with this.
Same thing on the other side. There's 1, 2, 3, 4, 5, 6, 7.
The Q2 would be 45.
Q3 will be 45. We look at the 7 data points above the median. 7 plus 1 over 2 is 4. We look at the 4th data point above the median, 1, 2, 3, 4. So this one right here, that's Q3. This one right here was Q1. Now that I have Q1 and Q3, what's the IQR?
41.
41. The IQR is Q3 minus Q1. So the IQR is 41. So Sarah, you had said something like 2 or 0.5? Huh?
I forget that I have to like count like 45. I just like count 5 and like.
I do not know what you mean.
Okay.
Kind of a little long.
You see, like I know that you have to like also count like 40. It's like you see the 4 in the other section, like 1, 2, 3, 4, 5. I forgot to count those. I only counted like 5.
Gotcha.
Sorry.
So you understand now.
Yeah, I know.
Okay, next question.
Question.
Yes,
On the calculator, when it says n equals 14.
14 data points.
Huh?
14 data points.
uh,
Are there any outliers here?
No, but you said we don't know.
Well, let's find out. Let's do the IQR test. What's the IQR test that I taught you? Don't say I didn't do it. We did it in class. Give me that look. What is the test for determining? No, I mean, 1.5 is nice, but you're not remembering the formula correctly. 1.5 times the IQR. It's the first thing we're going to do. What is 1.5 times the IQR here? 61.5.
Is it 61.5? Yeah, 61.5. Wait, what?
61.5.
I said 61.5, right? You all heard me say that, right? See, this is why, and this is, I'm all serious, this stuff right now. Stop immediately going to your calculator to do calculations that you should be able to do quickly in your head. Okay, you plug it in wrong, you write something down that makes absolutely no sense. 41 times 1 is of course 41. Half of 41 is 20.5. So 1.5 41s, 41 and 20.5, 61.5. Did that a lot quicker than it took me to even take out my calculator. Yes, you can. You just don't try. No, it does not take longer. I just did it so quick. I probably did. Huh? You don't get used to it. No, you know what? You know what? Not different times. Yes, remember an abacus? Anyone ever use an abacus? Neither did I, but apparently they're really cool. Anyways, when I was growing up, we had calculators, of course, but they weren't cheap and prevalent like they are now. I mean, they were pretty cheap, but they weren't prevalent like they are now. So we learned how to do math in our head.
I'm sorry.
It was tough, trust me. Anyways, so now that we have 1.5 times the IQR, and we have this number 61.5, how do I then take that number to infer whether or not I have an outlier? Or at least a suspected outlier? Yes?
Q1 minus whatever you have for that, the 61.5, so it would be negative 57.5.
Yeah, why even do that calculation? Once I see 4 minus this, and I see that I have had 2, doesn't even take the time to actually get that value.
Okay,
It's just obvious there's not going to be anything past that.
okay.
And then if I do Q3 plus that, 45, 61, it's already 100 something. Certainly way above 61. I don't even bother calculating the exact value. Okay, so no, 61 here is not an outlier, or at least not a suspected outlier. Yes, Annalise, you were going to say something. Alanis, right? Sorry, I have an Anais in my high school class. So, yes. You with the hand up, yes.
Yeah. So basically, I get it.
Good talk. Okay. Anyone else? Yes.
Where'd you get the 1.5 from?
That's the 1.5 IQR rule.
Oh, okay.
So 4 weeks into the class. 4 weeks into the class. At 8 lectures. At 100 minutes a lecture. That's 800 minutes. Even before today. That we have spent together. Which means it's expected that by now. You will have spent 1,600 minutes of your own time studying for this class. 1,600 minutes. How many hours is that?
26.
Something like 25, 26 hours, right? Who here has spent even close to that amount studying for this class?
Wait, you said 25 hours?
1,600 divided by 60. That's 800 over 30. That's 400 over 15. That's 26 and 2/3 hours. 26 hours, 40 minutes. Who here feels they spend at least 20 hours in this class? Total? A week. Okay, that's 16 hours. Solid amount. Not nearly what you need to do well in this class, but solid amount.
What if I start doing more hours now? Will I like end up catching up?
You do too much, you're gonna come back around the other side. It'll backfire on you. Yes, catch up. Do what you can. The formulas in this class so far are not complicated formulas. There's no calculus. There's no trigonometry. There's nothing more complicated than x minus mu over sigma to get your z-score. These formulas are not hard. But if you don't review them, then you don't know them, and then you can't use them, and you can't answer the most basic of questions. I understand today's review, but I'm going to be a little of a hard ass right now. Some of the questions, and questions are great, I'm not saying they're not, but some of the questions are just indicative that people are not doing anything or a minimal amount. And that will catch up to you very quickly if it hasn't already. You asked if it gets harder? I was lying before. Yes, it gets harder. Of course it gets harder. This is the easy stuff. Half of it's on your calculator, but if you don't know how to use your calculator or when to use it on your calculator, you can't answer questions. That should take all of 10 seconds to answer. So it's frustrating on my part when I'm trying to work with you and you're not doing what you need to do on your end. There's a contract, there's a bargain here. I teach, you learn. Or I try to teach, you try to learn. And both of them require lots of work and energy. I put in a lot of time outside of class, looking at the material, going over it, picking the questions I'm going to do or what I'm going to cover. You have to do on your end. It's just not fair otherwise. I want you all to do well. I really do. But if you don't work on your own, it's just not going to happen. Office hours, 6 o'clock to 6:30. Have the same 3 or 4 people coming every week. And the same 40 people not coming every week. Many of which are asking questions now that you should know. Come to my office hours. I've met with people online over weekends. Not often, only once or twice. And I'm willing to. I want you guys to do well, but you have to want to do well. And that means more than just showing up here. Yes.
Are the office hours like the same, like the kids are here and some on Zoom or only?
Oh, I don't even turn on Zoom. I mean, if someone said I can't make it, I'd log on Zoom to help them. But nobody's been on Zoom yet. I mean, it's right before our class. So if you're on Zoom, what are you gonna drive here afterwards? I mean, just, you know, you gotta be for class. That's why I put the office hours right by class so I can go one into the other. we will finish the review on Thursday.